Let's move on to some of the fundamental theorem of calculus questions. And for these problems, you need to calculate the antiderivative. And since you have a upper and lower bound, you're basically calculating the value of this definite integral. All right, so for step number one, you want to take the antiderivative of x to the power 2, and that's going to be x to the power of 3 divided by 3 plus, and then the antiderivative for x is going to be 4x to the power of 2 divided by 2. And because this is a definite integral, we're going to evaluate this from a lower bound of -1 to an upper bound of +3. And then from this stage, you're just kind of taking your upper bound and plugging it in for all your x values to start off. So let's do that. That's going to be 3 to the power of 3 divided by 3 plus 4 times 3 to the power of 2 divided by 2. So that's the first upper bound. So let's just put that in a bracket, and then we're going to subtract the lower bound. So now I take -1 and then I plug that in for all the x values. So then I need a separate bracket for that. That's going to be -1 to the power of 3 divided by 3 plus 4 times -1 to the power of 2 divided by 2, close the bracket. And your final step now is you have to numerically calculate this entire expression here. All right, so let's do this step by step. 3 to the power 3 is going to be 27, so 27 divided by 3 plus. Okay, now I have 3 to the power 2, which is 9, and 9 times 4 is going to be 36, so 36 divided by 2, and then minus, well, -1 to the power 3 is going to be -1, so that's going to be -1/3 in the bracket, plus, and then we have -1 to the power 2, which is going to be +1. +1 times 4 is going to be 4, so that's going to be 4 divided by 2. All right, so in that step right there, I kind of got rid of all the exponents, and then from here we can continue to evaluate. This is going to be 9 plus 18 plus 1/3, and 4 divided by 2 is 2, and then there's a minus sign, right? So that minus sign will make that -2. And once you plug all those numbers into your calculator or do that slowly, you would get 76 divided by 3 as a final answer. Remember, for definite integrals, when you have an upper and lower bound, you always have a numerical answer and not like a general antiderivative where you have plus c at the very end. All right, for this next question, I have a lower bound of 1 and an upper bound of 4. And before I find the antiderivative, it might be best to change that radical into a power. So let's just rewrite the problem so that everything is written in terms of a nice power. So a lower bound of 1, upper bound of 4, and then I have x plus x to the power of 1/2 times dx. All right, so let's take a look at the antiderivative of x. So I need to add 1 to the power here, so that's going to be x to the power of 2 divided by 2 plus, and then I need to add a 1 to this power, which is the same thing as adding 2 over 2, so that's going to be x to the power of 3 over 2 divided by 3 over 2. And all of this I can put in a square bracket, and I'm going from a lower bound of 1 to an upper bound of 4. And now we're using the fundamental theorem of calculus, where we always evaluate the upper bound first. So that's going to look like this. 4 to the power of 2 divided by 2 plus 4 to the power of 3 over 2 divided by 3 over 2. And I'll put all that in a bracket. And then the fundamental theorem of calculus states that I need a minus sign. And after that, I will now evaluate the lower bound. So now the lower bound goes in for all the x's. And let's just set up another bracket for the lower bound here. So that's going to be 1 to the power of 2 divided by 2 plus 1 to the power of 3 over 2 divided by 3 over 2. Okay, so basically all these colors, the 4, the 1, and the 1, those are my upper and lower bounds being inserted into back into the general antiderivative here, and now we need to calculate what this numerical value is. Okay, so if I take a look at this, 4 to the power 2 is going to be 16, and 16 divided by 2 is going to be 8, plus, now for the next one here, I would kind of do the problem like this. Here's a 4, and 4 to the power of this 1/2, well, 4 to the power 1/2 is 2, right? The square root of 4 is 2. So 4 to the power 1/2 is 2, and 2 to the power of 3 is going to be 8. So the numerator is going to be 8, and we'll divide that by 3 over 2. Minus, well, 1 to the power of 2 is just 1, so that's 1 over 2, plus 1 to the power of anything is 1, so 1 over 3 over 2. All right, so we'll take a multi-step approach to kind of get to this final answer here. I would just make sure that you know how we got the 8 there. And remember, I just did the 4 to the power 1/2 first. 4 to the power 1/2 is 2, and then 2 to the power 3 is 8. Okay, just to finish this off now, that's going to be 8 plus, and then 2 times 8 is going to be 16. So 16 over 3 minus the 1/2, and then this minus sign distributes, so minus, and then the 2 times 1 is 2, so 2 over 3. And then if you add up all those numbers and subtract the numbers as well, you get 73 over 6 as a final answer there. Okay, let's move on to the third question now. For question number 4, I need to find the answer here for this definite integral when I have 1 over the cube root of x. So step number 1, let's just rewrite our problem so that we have a power here. So this is going to be x to the power of -1/3 times dx. All right, so whenever you have your problems written in terms of powers, the antiderivative is a lot easier to calculate. So x to the power of -1/3, I need to add 1 to that, so that's the same thing as adding 3 over 3. So this is going to be x to the power of 2/3 divided by 2/3. And this is going all the way from a lower bound of 1 to an upper bound of 8. All right, so once we find our general antiderivative, let's use the fundamental theorem of calculus to find the numerical answer here. So let's start with 8 first. 8 goes in for x, so that's going to be 8 to the power of 2/3 divided by 2/3 minus, and then now we need to evaluate our lower bound of 1, so that's going to be 1 to the power of 2/3 divided by 2/3. So now we need to calculate this weird looking expression here. Let's just start with the numerator on the left hand side here. I have 8, so think about 8 to the power of 1/3. 8 to the power of 1/3 is going to be 2, and then 2 to the power of 2 is going to be 4. So the numerator is going to be 4, and then I divide that by 2/3 minus, well, 1 to the power of anything is just 1, so I have 1 divided by 2/3. All right, we're almost done here. Now we can just do some multiplication here. 4 times 3 is going to be 12, so 12 divided by 2 minus 3 times 1 is 3, so 3 divided by 2. And 12 minus 3 is going to be 9 divided by 2, which is roughly 4.5. So 4.5 is my final answer for that one. Okay, let's move on to question number 5. And for question number 5, before we start finding the antiderivative, we may want to simplify the original problem because we're dividing by x cubed. All right, so let's put an equal sign there and integral sign 3 to 1. And let's go ahead and write this in terms of individual fractions first. So this is going to be 4x to the power of 4 divided by x cubed minus 6x squared divided by x cubed minus 9x divided by x cubed times dx. All right, so we're going to write this all in terms of individual fractions, and then we're going to go ahead and simplify each individual fraction here. So this is the integral from 3 to 1, and then I'm left with 4 times x minus I have x squared over x cubed, which will be 6 over x, minus then I have x divided by x squared, which is the same thing. Sorry, I have x divided by x cubed, which is the same thing as 9 over x squared, and then that's dx. All right, so after we simplify this, let's go ahead and take one extra step here to write this in terms of a power if I can. So that's going from 3 to 1, and now I have a 4x minus. Now this fraction here, I'm going to write that as 6 times 1 over x. And then I'll write this as minus 9x to the power of -2 times dx. Okay, so there is my simplified version here, and once I have my original problem written in this format, I can find the antiderivative a lot easier. Okay, let's start off with 4x. Let's go ahead and find the antiderivative now. I need to add 1 to the power, so that's going to be 4x to the power of 2 divided by 2 minus 6. And the antiderivative of 1 over x is going to be ln x. Remember, the derivative of ln x is 1 over x, so the antiderivative of 1 over x is ln x. Minus 9, and then I need to add 1 to that, so that's going to be x to the power of negative 1 divided by negative 1, and that's going from a lower bound of 3 to a higher bound of 1. Okay, let's go ahead and simplify this before we actually start plugging the numbers here. So 4 divided by 2 is going to be 2, so 2x squared minus 6 ln x. And then you'll notice that there's a minus and a minus, so that's going to be plus 9, and this part right here, x to the power of negative 1, I can park that down on the bottom as 9 divided by x. And now all of this is going from a lower bound of 3 to an upper bound of 1. All right, now let's use the fundamental theorem of calculus here. So the 1's will go in first. So this is going to be 2 times 1 squared minus 6 times ln of 1 plus 9 over 1. So that is the upper bound right there. Minus, and now we need to calculate the lower bound. So let's take our lower bound of 3 and let's plug that in for all the x's. And let's have a separate bracket for that. So that's going to be 2 times 3 to the power of 2 minus 6 times ln of 3 plus 9 over 3. And then we'll close the bracket there. And after that, let's just go ahead and do our best to evaluate all the individual terms. So 2 times 1 squared. Well, 1 squared here is just 1. So 1 times 2 is just 2, minus ln of 1 here is just 0, so this whole thing is just gone, and plus 9 over 1 is just 9, so it's going to be 2 plus 9 for that first bracket, and that's because this middle term is going to 0. And then I have a minus sign. All right, and then I have 2 to the power 3. 2 to the power 3 is going to be 9, and 9 times 2 is going to be 18, so minus 18. And this right here, minus 6 ln 3, I can write that as minus 6 ln 3, plus, and then 9 divided by 3 is just 3, and then I can close the bracket there. And then from here, I mean, you're just evaluating things. 2 plus 9 is 11, minus 18, plus 6 ln 3 minus 3, and if we add up all the terms here, we should get 6 ln 3 minus 10. So that's your final answer for that particular problem. Okay, let's move on to the last question for this particular video here. The last one is a trig function. So we're going to find the antiderivative of some of these trig functions here. Over here on the side, I just have some of these references that you can find on your formula sheets. I think all 4 of these things I've highlighted in yellow are pretty important for this particular problem. So for example, if I want to find the antiderivative of tan theta, let's just follow the reference sheet here, and the antiderivative of tan theta is ln absolute value of secant theta. And then there's a minus sign in the middle, so minus. And now what's the antiderivative of secant theta tan theta, which is right here? The antiderivative of secant theta tan theta is just secant theta, so minus secant theta. So that's my antiderivative there, and now I'm going from 0 to pi over 3. Okay, and now we're using the fundamental theorem of calculus, where I take my upper bound of pi over 3 and I plug that in for all my theta values. So now this will be ln absolute value of secant pi over 3 minus secant of pi over 3. That's the first part, and I will put all that in an orange bracket, minus the lower bound. And the lower bound now here is 0, so let's plug in 0 for all the thetas now. So let's put another orange bracket here, and that's going to be ln absolute value of secant of 0 minus secant of 0. And from there, you need to be able to evaluate what this is going to turn out to. If I'm looking at secant pi over 3, let's go ahead and take a look at this factor right here. If I know that cos of pi over 3 is 1/2, that means secant theta, which is its reciprocal, you just got to just flip these around. So that means secant pi over 3 is going to be 2 over 1, which is just 2. So that means ln of secant pi over 3 is going to be just secant pi over 3 is just going to be 2. So this will be ln of 2, close the bracket, minus, and secant pi over 3, as we mentioned, is just going to be 2. So that first bracket simplifies to ln 2 minus, and then secant of 0, well, go to cos of 0 right here. Cos of 0 is 1, and that means secant of 0 is going to be, 1 over 1, or the reciprocal of that. So the reciprocal of 1 is just 1. So that's going to be ln of 1 minus, and secant 0 is just 1. All right, so in order to find these values, the 2's, the 1's, and the 1's, you have to use the facts over here in this green box, in this green area over here, to find the exact values. After that, let's just go ahead and execute this. This is going to be a ln absolute value of 2 minus 2 minus ln of 1, and then plus 1 at the very end. And we know that ln of 1 is 0, so now I have ln of 2, and then negative 2 plus 1 is minus 1. And that's your final answer there.